Assalamu alaikum everyone. Today we are going to discuss few important concepts of photochemistry. So let's start from the basic. This is a molecule A. These are the atoms within which electrons are present. So initially when the molecule has not absorbed any kind of radiations and all the electrons are paired or having opposite spin, then the molecule is said to be on singlet ground state, which is a stable state denoted by S0, where S stands for singlet and 0 stands for ground. Upon absorption of energy, molecule A electronically gets excited to any of the singlet excited states S1, S2, S3, and so on without changing its spin. So keep in mind that a molecule, as long as it's in singlet state, whether ground or excited, its electrons will always have pair spin until it goes to the triplet state. But a molecule can never directly excite to a triplet state. It can go to a singlet excited state and from there move to a triplet state, but by flipping its spin. Because triplet state is associated with unpaired spin or same spin. So after some time, molecule A gets de-excited to singlet ground state again by releasing the absorbed radiations. But de-excitation occurs in two ways, either in the form of fluorescence or phosphorescence. So basically, fluorescence and phosphorescence are the two different categories of photoluminescence, which is the emission of light due to the absorption of photons. Now, Jablonski diagram will help in better understanding of the both processes, but before we get into that, there are few terms which need to be discussed. So there is a frequently asked question that why emitted radiations are always of lower energy or higher wavelength than the absorbed radiations. Let me tell you why. So this difference between the wavelengths of emitted and absorbed radiation is known as Stokes shift. You see, absorption occurs at 550 nanometers and emission occurs at 600 nanometers. So there's a difference, or you can say that a Stokes shift of 50 nanometers. Intensities of both radiations would be the same, but their wavelengths and energies are different. Wavelength of emitted radiation is greater, means energy is less, because both are inversely related. So basically, the Stokes shift arises due to some non-radiative processes that occurs during the excitation of a molecule. Note that excitation is a smooth phenomena where molecules absorb energy and get excited to different electronic levels depending upon their energies. But de-excitation is quite complex, where molecules have several radiative and non-radiative pathways. So the first one is vibrational relaxation. S1 is the first singlet excited state. It is an electronic level which is further divided into vibrational levels. There are rotational levels within vibrational levels but are not of our concern. So the process occurs when a molecule moves from higher vibrational level to lower vibrational level without releasing any radiation. Energy might lose in the form of heat, but that's not useful. So we consider this process as a non-radiative relaxation of a molecule. Second is internal conversion, which is also a non-radiative relaxation where molecules move from higher singlet excited state to lower singlet excited state. This is because some of vibrational levels of both excited states overlap due to comparable energies. So molecule can easily move between them without radiating energy. Same is the case with intersystem crossing, where molecules move from singlet excited state to triplet excited state due to overlapped vibrational levels. But the difference here is a change of spin multiplicity, because electronic spin is different for both electronic levels. So these three non-radiative pathways are responsible for generating the Stokes shift, due to which emitted radiations are less energetic than the absorbed. Now come to Jablonski energy diagram and learn some more about fluorescence and phosphorescence. So this is the figure. S0, S1, S2, and T1 are the different electronic levels within which vibrational levels are shown. Actually, these energy levels are not physical, where molecules can go, stay, and come back. They're just the virtual state of a molecule upon absorption or emission of energy, as we discussed earlier in the video. So you can see here, when molecules absorb energy, they get excited to any of the vibrational level of any singlet excited state on the basis of absorbed energies. Whereupon de-excitation, they may go through vibrational relaxation and internal conversion. Then they have two options. Either they directly go from S1 to S0 by releasing radiation in the form of fluorescence, or they go from S1 to T1 through inter-system crossing and then from T1 to S0 by releasing radiation in the form of phosphorescence. Now the difference between both processes is that fluorescence is the immediate process which occurs within nanoseconds and stops when the excitation source is removed, whereas phosphorescence is the delayed process due to the involvement of metastable state T1 and the change of spin multiplicity twice. So the emission persists longer even after the removal of excitation source. So this was all about basic photochemistry. I hope everything is well explained, and it is something that remain unclear, you can ask in the comment section. See you in the next video. Till then, goodbye, Allah Hafiz.